Hello everyone, this is Prashant Vistalkar. In this video, we'll see how to get the average value of rainfall for a basin if the graded rainfall data is available. So for the demonstration purpose, I have downloaded the rainfall data for India. So this is the website. Here you can download the graded rainfall data. Uh, the spatial resolution is 0.25 degree by 0.25 degree, and the data is available from 1901 to 2018. So I have selected the year 2017 for the demonstration purpose. If you plot this data uh, in some GIS software, it will look like something this. So here I have used the ArcGIS software. So this is the rainfall data for a day of uh, July 1st, 1949. So the low value is 0 and the high value is 158.2 mm per day. So I have one basin called as basin or catchment. So its name is Karad. It is near the Western Ghat, and I want to find out what is the average value of the rainfall for this basin. So if you plot this basin over the rainfall data, it will look like this. So you can see uh, yes, so in this figure you can clearly see the pixels here. It was not visible in the earlier case, but if you zoom in you can see it clearly. If you zoom further you can see the pixels very clearly here. So this white basin is the Karad basin. So I want the average rainfall for this basin. You can see some of the pixels are completely inside the basins, but some pixels are partially. Sorry. So if basin size is rectangle, for example I have shown here this black basin. It's a ideal basin. You will not get this kind of basin in real size. So just for the demonstration purpose. So if consider this is the basin, if I want to get the average value for this basin, so what will I do? You just select the average of all the pixels falling inside the basin. But as I mentioned, in reality this might not be the case. In reality, the basin shape will be very irregular. So in this case, you can see, so this pixel is not completely falling inside the basin. So in that case, what we do, we find what is the overlapping area. Suppose this pixel is overlapping with this basin 25% by area. Similarly, if you consider this pixel, the overlapping area is just 10%. So in this case, we take a weighted average. Means so in weighted average, what we do first, we calculate weight based on the area and multiply this weight by the value. So if you are taking the weighted average, so it will come as like W1 X1. So X1 is the rainfall value for this pixel. Similarly W2 X2. So W2 is the weight overlapping. What is the overlapping area? So that is nothing but the W2 into X2 is the rainfall value for that pixel. Similarly W3 X3 W4 X4 and divided by W1 W2 W3 W4. So this will give the weighted average rainfall for this basin. So that will be the accurate method. In another case, what you can do, so just taking the average, that means even if this pixel is falling partially inside the basin, consider this whole pixel and just take the average. Means like W1 plus W2, sorry, X1 plus X2 plus X3 plus X4 divided by number of pixels. So that is just a normal average. But in this case, even if the pixel is overlapping with the basin partially, you are considering as it's completely inside the basin. So that is creating error. That's why we normally take a weighted average, that is w1x1 plus w2x2 plus w1xn divided by w1 plus w2 plus w3 plus w. So we'll see how to use how to implement this in a MATLAB. So coming to the MATLAB, so you might have downloaded the data required for the demonstration. So go to the folder where you have downloaded the data, that is average rainfall, then copy the link and paste it here. You can see the different files here. The shape file is it's a sample file. You can see the whatever the figures I have shown in the slides. You can see the figures in which shape file folder. So average rainfall is the main code. The clip raster polygon is the function someone has written, and I'm calling this function inside this average rainfall. And these are the shape files. Rain.mat is the rainfall data for the India. So now I will open this average rainfall file. Okay, so we'll load the data in the MATLAB workspace. So as I mentioned, we are going to use the 1 year rainfall data for the India. So if you see this variable rain underscore day, if you open it, the size of rain underscore day is 365 cross 1, means that each cell is the rainfall data for 1 day, and each cell has a matrix of 121 cross 121. That means the first cell is the rainfall data for whole India for day 1. Second matrix is the rainfall data for whole India for day 2. Similarly, third cell is the rainfall data for whole India for day 3. And if you want to find out what is the date for that day, you can see here. So the first day is 2017 1, 2017 January 2nd, 2017 January 3rd. Okay, so if you open 1 day rainfall for whole India, it has a size of 121 cross 121. So none means there is no value, and this each value is corresponding to 1 pixel. So we have a size of the matrix size of 121 cross 121. That means 121 cross 121 pixels. And if you want to know what is the latitude of that pixel, you just go to the lat. Similarly, long. Suppose if I select a pixel, so this 50 and 30, this pixel, if I want to know what is the lat of this pixel, what is the location coordinate for this pixel, I will go to the lat. What is 15, that is 34, and what is the long, 30. Okay, 30 corresponding to 30 column here, 74. So the location of this pixel is 34 lat and 74.75 long. Similarly, you can find for all the pixels. That's why if you see the size of our lat and long, it's 121 cross 1 and long is 121 cross 1, and our matrix size is 121 cross 121. So if you plot this rainfall data, suppose if I want to see the rainfall data for 1 day, so select the lines from 12 to 19 and run it. So it will plot the rainfall data for whole India for 1 day. And here you can see the day is 200 day. 200 means what is the date for that one. So you can see here 200. Yeah, 200 is, it's a July 19th. So India, that is a rainy season. So you can see the rainfall clearly here. It's raining here, it's raining the western ghats. The maximum value is 180 mm per day. Obviously, if you take a January or May month, it will come as completely 00 E. So for that day, there will be no rainfall at all. So I'll select nearly about 150 day. Still, some pixels have the rainfall for this one. So I think it might be the start of rainy season. I'll select 100. Yeah, you can see it's completely zero now, most of the pixels. Okay, so if you want to plot data for a particular pixel for 365 days, I have created one more variable, that is rain. It's just arranging this 365 into cell time series. So if you run this line, it will plot a rainfall for pixel 150 cross 50 for 365 days. Yeah, so here you can see on x-axis the Julian days. The Julian day means the January 1st is the first day, and accordingly you increase the number. So last day will be the 365th. If it is a leap year, then the last day will be the 366. So here you can see this is the summer, this is the rainy season, and this is the winter. You can see clearly seasons here. Okay, so as I mentioned, next step is to crop or to get the rainfall data for the Karad basin. So I am loading the shapefile for the Karad. So you can see the shapefiles I have put here. So I will read the shapefile in MATLAB now. It's reading. So it will load the details of that shapefile. So if you open Karad, it's a structure file. So it's a bounding box. X is the longitude and Y is the latitude. So these are the longitude points for that shapefile, and these are the latitude points of that shapefile. Okay, so sorry. So next thing is basically it's reading the lat and long. Based on the lat and long, it's cropping. So shapefile has a lat and long, and I need to assign the lat and long to the matrix also. So this is our rainfall matrix. So this is the rainfall data for whole India. So I will assign the lat and long to this matrix. Already we have lat and long, that is 121 cross 121, but it's the center value for each pixel. That means, so I have assigned the lat and long to the center of this pixel, similarly center of this pixel, similarly center of this pixel. But this function, that the function which I am going to use, it need the lat and long of the edge of that pixel. Means I will assign the lat and long to the here at this corner, here at this corner, here at this corner. So imagine you have one pixel. If I assign the lat and long to that pixel, center to that pixel, it will come as only one value. But if I assign the lat and long to the edge or corner of that pixel, obviously the two values will come. That's why when I assign the lat and long to the each corner of this matrix, that is 121 cross 121, so it will the lat and long dimension will change, and it will come as a 122 cross 122. So I am creating that lat and long. Okay, so here you can see r lat and r long. So latitude, as I mentioned, it's 122 cross 1, and r long is 120 cross 1. 122 cross 1. So here I have converted r long into a single column. Similarly, latitude is already a column matrix, but I have converted r long. If you see, the original long is a row matrix, but now I have converted into a column matrix. This is the requirement of the function I am going to use. So in this loop what I'm doing, basically I'm cropping for each day. I have 365 days, so this loop, what it will do, it will crop for day 1. That means it will crop this matrix for that basin. Similarly, it will crop this matrix for that basin for second time. That's why I have used the loop here. Okay, here I am defining the uh, latitude of that shapefile and longitude of that shapefile, and finally I'm saving the output in this rain underscore average variable. And here is the main function, that is called clip raster polygon. This is the function somebody has wrote. I got it online. It's not MATLAB inbuilt function. So it takes an input in a sequential order. So you just call this function, give the matrix that you want to crop, that is the rainfall for first day for whole India, then give the latitude of this matrix. But remember, it's a not a central center value of that pixel, it's a corner value. Similarly, give the longitude uh, for that data, and then latitude of that polygon, that is my shapefile, and longitude of that shapefile. And here this function gives the option to get the average value by two methods, as I mentioned. One is average by area. Okay, so we'll see the first method. I will run this one. So it will calculate the average by area, as I mentioned, that is w1 x1 plus w2 x2 plus dot 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 w1 x1 divided by w1 plus w2. So w is the overlapping area between the pixel and polygon. So it will take little time. You can see here it's running, it's saying busy, that means it's running. Yeah, it will take little more time, because it needs to estimate what is the overlapping area for each pixel. Yeah, it's taking little more time than expected. It's still working. I should have given a 3D matrix instead of this uh, 365 cross 1. If I give a matrix of 121 cross 121 cross 365, it would have taken little less time. But it's okay. That would be a little bit difficult to understand. That's why I gave this 2D matrix. Yeah, it's done. Okay, so what is the output? Rain underscore average. Okay, you can see here in the summer season the rainfall is zero, almost zero. Yeah, some rain here and then here. Okay, I'll plot this one. So okay, it's looking something like this. So this is uh, sorry. So this is the average rainfall for the Karat basin. So the x-axis is the Julian day, and y is the rainfall in per day. So this is we estimated using the weighted average. So I will take a sum of rainfall through over a year, so that we'll check sum rain underscore avg. So it is coming as 1009. Correct, 1 2 3, yeah, 1009 per day, sorry, per year. So this is the e to the power 3 means 10 to the power 3. So this, for this basin, the annual rainfall is 1000 per year. So in the next case, what will you do? As I told, we will just calculate the average. AVERAGE. So in this case, instead of uh, considering the overlapping area between the pixel and the basin shapefile, even the pixel is partially overlapping with the basin, it will consider as a it's completely, it will consider it's completely inside the basin, and it will just take a average of all the pixels. So we'll see. Okay, I will run everything again. Okay, yeah, let's selection. And this time it ran fast. Okay, so I'll plot this now. Okay, this is the rainfall for that basin. Okay, I'll take a sum now. We'll see sum of rain underscore avg. So it is coming as nearly about 1800 per year. You remember last time when we took weighted average, it was nearly about 1000. Now it's like 1800. So there is a error of nearly about 800 Why? Because I'll tell you. If you see this pixel, so red means the zero rainfall and the green is the high rainfall. When we are taking the weighted average, in that case we are assigning the weights to this pixel. We are not considering this complete pixel. That's why we are getting the less value. But in the next step, when we are considering the just average, it is considering this whole pixel, and it's calculating the average. That's why it is giving the more importance to this pixel. Even it's not falling completely inside the basin, and it has a very high rainfall. So you can plot this too using like just average and weighted average and see the you can see the clearly difference by plotting. Okay, thanks. This is all about this video. Thanks for watching.